Yes, sir. I've understood the why we study about construct.
Construct is the concept, abstraction of the concept. For example, you are talking about the environmental attitude. So this pro-environmental attitude is the construct because you cannot see it. It is intangible. Therefore, it is construct. In geography, you can find out many constructs. In any subject, you will find the constructs because everything is not visible. Okay.
Yes, sir. Understood.
So we can conceptualize. That is the thing. Okay, dear student.
Sir, I had one more doubt.
Yeah.
Sir, the test that we conduct on SPSS, like the t-test and the chi-square test, will you teach us how we will be interpreting that?
Yeah, I will discuss that one. Already I have done it. But again, I will discuss definitely. Anything more?
No, sir. Thank you very much, sir.
Okay. So please go to the Google Classroom. Hima?
Good evening, sir.
Good evening, Shima. Please go to the Google Classroom. There yes, I have written inferential statistics.
Ji, sir.
Please you read it.
Today's topic is inferential statistics. Inferential statistics play a pivotal role in modern data analysis, providing researchers with powerful tools to draw meaningful conclusions from data samples and make predictions about populations. This essay explores the significance of inferential statistics in various fields, emphasizing its application, benefits, and challenges. Introduction. Inferential statistics involve making inferences or predictions about a population based on a sample of data taken from that population. It utilizes techniques such as hypothesis testing, regression analysis, and confidence interval to draw conclusions about larger data sets. The primary objectives is to generalize findings from a limited data set to a broader context, allowing researchers to make informed decisions. Applications of inferential statistics. Inferential statistics find applications in diverse fields, including healthcare, economics, social sciences, and natural sciences. In healthcare, clinical trials employ inferential statistics to determine the effectiveness of new drugs or treatments. Economists use these techniques to analyze market trends and predict economic outcomes. Social scientists utilize inferential statistics to draw conclusions about human behavior and attitude, enhancing our understanding of society.
Thank you. Thank you. Stop. Now I am requesting Komal. Komal, please start benefits of inferential statistics. Hello, Komal, are you available?
Yeah, yes, sir, I'm here. Give me 1 second, sir, please. The benefits of inferential statistics, no? Hello?
Yes, yes.
Precision. Inferential statistics provide precise estimates and predictions, enabling researchers to make well-informed decisions based on limited data. Generalization by drawing conclusions about populations from samples. Inferential statistics allow researchers to generalize their findings, making their studies applicable to broader contexts. Decision making, businesses and policymakers rely on inferential statistics to make critical decisions, enhancing efficiency and effectiveness in various segments. Challenges in inferential statistics. Sampling bias. Biased samples can lead to inaccurate conclusions. It is crucial to ensure that the sample is representative of the entire population. Misinterpretation. Inferential statistics can be complex, leading to interpretation of results. Proper understanding and the communication of findings are essential to prevent misunderstanding. Assumptions. Many inferential statistical methods rely on specific assumptions about the data. Violating these assumptions can lead to unreliable results. Conclusion. Inferential statistics serves as the backbone of modern scientific research and decision-making processes. Their ability to analyze limited data and draw meaningful conclusions about population is invaluable. However, it is essential for researchers to be aware of challenges and limitations associated with these techniques to ensure accurate and reliable results. As a technology advances, the application of inferential statistics will evolve in shaping the future of research and data-driven decision-making across various disciplines.
Thank you. Thank you, Komal. Okay, Supriya, can you tell what is the inferential statistics?
So, sir, in inferential statistics, it can tell us what is the meaning of this data. We can journalize the data and make predictions about a population. So we take a sample, that sample should be representative of a population. So whatever description we have found from descriptive statistics, that can be used to make predictions about the population.
Okay. So inferential statistics involves making inference or prediction about a population based on a sample of data taken from that population. Okay.
Yes.
So what is sample? Sukarna,
The sample is
Sukarna, are you here?
Yes, sir.
Can
Which
you
you
tell
take
me
for
what is sample?
which you take for case study?
No. Kavita, can you tell what is sample?
Sample is the representative, a smaller set of data that represents the whole lot of population.
Yeah, sample is the representative of population. So why do we collect the data from the sample? Nishu? We can collect data from the sample. Why sample?
Because it is
So
quite
because
difficult.
it is
Am I audible?
Because
It is quite difficult to collect the sample from the entire population, so we pick out a sample.
very good. Inferential statistics deals with hypothesis testing. So what is hypothesis testing, Shima?
Sir, on the basis of previous findings, we make some hypothesis or draw some tentative answer for our question. To test these hypotheses is called the hypothesis testing by statistical methods.
Yeah, so it is hypothesis is tentative assumption. And there are two types of hypotheses. Okay, Sukarna, can you tell?
No, sir. I have to
Acha.
study that.
Okay. Poonam, what are the two types of hypotheses?
So one hypothesis is null hypothesis, where we don't set any direction for the study. We say that there is no significant difference between the variables. And another one is the positive or directive hypothesis, where we set the direction of the current research. What kind of findings we will get. There will be a positive inclination or result of the variables after the study.
Yeah, so that is called the alternate hypothesis.
Okay, yes,
Very
sir.
good. So why do we study hypothesis? Why do we test hypothesis?
So, sir, like our hypothesis can be that our two variables are associated with each other, and null hypothesis can be that there is no relationship between the variables. So, when we are testing out the hypothesis, then we can verify whether these two variables are actually significantly associated with each other or not.
But why we are using hypothesis? Yes, Shema, you want to say something?
Sir, because a hypothesis gives the direction to our research.
Very good.
That's why we use
Direction.
hypothesis.
Yes. It gives the direction of our research. Now, inferential statistics requires hypothesis testing and confidence intervals. What do you mean by the confidence intervals? Poonam, can you tell?
Sorry, sir.
Okay. How much reliability we can allow for your data?
So, sir, we take significance value. If we are taking significance value to be less than 0.05, then our confidence interval is 95%. If we are taking significant value to be less than 0.01, then our confidence level will be 99%. Like this, right?
Yes, correct, correct. Very good. Very good answer. Now, Kavita, your subject is geography, okay? And in geography, do you use any mean difference test?
Sir, actually, I haven't studied yet, but yes, we study something like that, ANOVA test and all that.
For example,
Sir, I don't
basically
have.
in geography, you are dealing with the landscape, correct?
Yes, sir.
So you can find out the difference between the two types of landscapes.
Yes, sir.
Okay,
Sir, and
now,
it's not
for
only about the
example,
landscape.
in case of the landscape, what will be the parameters of landscape? Your subject
height.
is geography, so I am asking you
Yes,
this
sir.
question.
Yes, so the elevation and the
Yes.
maybe the vegetation. vegetation cover, and the slope.
Very good. So these are the parameters. So
Yes,
when
sir.
you have those parameters, then you can make the difference between the two groups, two types of landscape.
Yes, sir.
For example, landscape in the eastern side of India and the western side of India.
Yes, sir.
Okay, the two different types of ranges of the mountains. And why this difference is there, so that is your function. But you can definitely assess.
Yes, sir. Yes, sir.
Okay. Shukarna, what is your subject? Hello, Shukarna.
Sir, nutrition.
Okay. Now related to the nutrition.
Yes.
So can you think of any mean difference test in nutrition? Any hypothesis?
No, sir.
Nutrition subject, nutrition deals with which issue?
It's related in diet. What we eat in therapeutic conditions like in diseases and in to lead a healthy lifestyle. What we eat, that's all nutrition.
Okay. That means there are some fruits. Okay.
Yes,
And there are some vegetables.
yes,
And these vegetables has some nutrients.
yes,
And what is the effect of those nutrients on the human body?
yes, sir, yes, sir.
So that can be your hypothesis. Okay.
So what are the result? Hypothesis means.
Yeah. So it will be your tentative assumption. For example, lemon, the orange. Is orange is related to the kidney disease or not?
Oh.
Whether the patient suffering from CKD, okay, and orange has some nutrients. Does orange has any effect on the
Yes, sir.
CKD patient?
This is the hypothesis. What are the outcomes?
So that will be tested by you.
Oh, no, no,
How I
sir.
can
What are
say?
the outcomes? That will be the hypothesis.
So no, this is the question.
Okay.
This is the question. So there will be some hypothesis. So maybe the hypothesis will be there will be no
Assumption is
significant difference.
hypothesis.
There would be no significant mean differences in the severity of CKD between the patients of lemon eating and the non-lemon eating.
Yes, sir.
So that may be the hypothesis. One second. হ্যালো, হ্যাঁ, তোমার বইটা নিয়ে নাও। হ্যাঁ, হ্যাঁ, ভালো আছি। হ্যালো, আমি কি পড়াচ্ছিলাম? Yes, Shukan, I think now you have understood the effect of nutrition
sir,
on
yes, sir.
CKD. Now
Yes,
you
sir.
have understood. I think other subject is psychology, right? Or is there any other subject? Supriya, your subject is psychology, no?
Yes, sir.
Yeah. Subrata, your subject is nursing. Subrata, are you here?
Yes, sir.
Your subject is nursing.
Nursing, yes.
So in nursing, how you can apply the hypothesis model?
If the intervention is increase the outcome on this type of any intervention increase the outcome.
Yeah, so that is if
Or
there are
decrease
different types of nursing, I have no idea.
yes.
You can tell that is
Medication
whether
or any
nursing has
therapy.
different types or not, and its effect on the patient care or patient satisfaction.
Yes, sir.
So patient satisfaction will be your dependent variable.
Yes, sir.
And the independent variable will be the
Intervention, nursing intervention.
nursing intervention.
Yes, sir.
Okay. Now everybody has clear idea about the hypothesis. What is hypothesis? Why do we study inferential statistics?
Yes, sir.
Okay. Now I am requesting Supriya. Please
Yes,
you go
sir.
to the Google Classroom.
Okay.
There is type 1 and 2 errors.
Yes, sir.
So please you start read.
Okay. Type 1 and type 2 errors are critical concepts in hypothesis testing, representing the potential mistakes researchers can make while interpreting statistical results. Type 1 error occurs when a true null hypothesis is incorrectly rejected. In other words, it happens when the data suggests a significant effect or difference when, in reality, there is none. The probability of committing a type 1 error is denoted as alpha and is typically set by researchers before conducting a study. Commonly used alpha levels are 0.05 and 0.01, indicating a 5% and 1% chance, respectively, of making a type 1 error. Type 1 errors are also known as false positives. For
So
example,
is it, yeah, sorry, Supriya, now
yes,
type
sir.
1 error is called the false positive.
Yes, sir.
Why it is called false positive?
So, sir, for example, if you are taking a pregnancy test and you are not actually pregnant, but the test is showing you that you are pregnant. So that is an example of a type 1 error. It is a false positive.
Okay. Now who will read? Nishu, please you read type
Yes.
2 error.
Yes, sir. Type 2 error occurs when a false null hypothesis is not rejected. It happens when the data does not show a significant effect or difference, even though there is one. The probability of committing a type 2 error is denoted as beta. The complement of beta, that is 1 minus beta, is called a power of the test, representing the probability of correctly rejecting a false null hypothesis. Type 2 errors are also known as false negatives. For instance,
So
in a
why
case
is it called false negative, Nishu? False negative. Please you read again, then you can find out.
yes,
A type 2 error occurs. Please you read.
yes, sir. For type 2 error, it occurs when there is a change, but it is not being detected.
Yeah, when a false null hypothesis is not rejected.
Yes, sir.
Therefore, it is called the false negative.
False negative.
Okay. For instance, Dhanushi, can you read from the for instance?
Yes, sir. For instance, in clinical trial testing the effectiveness of a new drug, a type 2 error would occur if the drug has a significant positive impact but the study fails to detect it. This could lead to the drug not being approved or prescribed when it could have been beneficial. Balancing type 1 and type 2 error is crucial in experimental design. Researchers must decide the acceptable level of risk for each error based on the context of their study. A more stringent alpha level reduces the risk of type 1 error but increases the risk of type 2 error, and vice versa. Understanding and minimizing these errors ensures the integrity and reliability of statistical conclusions, enabling informed decision making in various fields.
Wow, very nice. So can you tell me that it is written a more stringent alpha level reduces the risk of type 1 errors. So what do you mean by the stringent alpha level reduction?
So for example, if I'm keeping my alpha level at 1%, 0.01, and I'm testing out a medicine if it is effective or not, and I'm only taking 1% margin of error. So uh, maybe my data will say that it is not effective, but it was effective in 95 or 96% of the population. So uh, so because I'm too stringent with my alpha, so that is why I'm making type 2 error in this.
Yeah, so you have to reduce the number of errors.
Yes,
Therefore,
sir.
it will be the 99% should be correct.
Yes, sir.
Should be
I'm
effective.
taking it
Yeah.
should be effective on 99% people. But if I
Mm.
would have taken 5% error, then it would have shown me that it was statistically significantly it is showing positive results in 95 or 96% of the population. But because I was so stringent, then I rejected the medicine that no, it is not working. But it was working on 96% of population. That is why I committed type 2 error because I was too stringent with my type alpha.
Very good. Kavita, is it clear now?
Yes, sir.
Sukarna, clear?
Yes,
Or
sir.
still you have any question?
No, sir.
Okay.
So you are not audible.
Okay, okay. This is visible to all of you?
Yes,
Yes,
sir.
sir.
Okay. Now, here you can find out the two groups are there. 1 and 2. And these
Yes,
two
sir.
groups, yes, these two groups are there. So that is the independent variable. Okay. And this is the dependent variable. So this total score is the dependent variable. Okay. Or all the variables, maybe 8 or 10 variables are there. So all the variables are also dependent variable. Okay. Therefore, what I can do, I can click the analysis. Analysis visible to all of you?
Yes, sir.
Okay, analysis. After that, I can click the compare means. Okay. And there are two things are there. One is one sample t-test. Is it visible to all of you? One sample t-test?
Yes,
Yes,
sir.
sir.
Okay. So only one sample t-test. I can use the total score. This one. Okay. And the options are there. It is written confidence intervals. This is visible.
Yes, sir.
Okay, so it is written confidence interval percentage. Okay. Continue. Then okay. So what I have received, the t-test, it is a one sample
It's
t-test.
not visible.
Oh. This is visible now?
Yes,
Yes, sir.
sir.
Okay. So here you can find out the total score is 36.71. Okay. So this is the mean. And this is the confidence interval, 36.04 to 37.38. Okay. And this is significant. This is one sample t-test. One sample t-test is telling you, that is, you can consider the data which is 36.03 to 37.38. Sorry, 36.04 to 37.38. So that is your confidence interval. So these data you can rely. Okay, this much data you can rely if you think about the 0.05 level of significance. That is the 95 confidence interval of the difference. Okay, and this is the standard error of mean. This is standard deviation, and this is the so these data you can consider as the
Sir, if the standard deviation is 4.9, then how can the 95% confidence interval only be 36 to
because
37?
yeah, because this is only the sample mean and the sample standard deviation. So it does not make any inference, but this makes inference. Therefore, I am using the significance level. Okay. Therefore, it is inferential. So initially, one sample test that you are doing. So then you can tell that is this lower limit is 36.04 and the upper limit is 37.38. Now, another thing is there. I am going to the analyze again. Compare means. Independent sample t-test. Okay. So if it is independent sample, then I click it. So I have to show that is which data I want to analyze. Suppose I want to analyze all the variables. Even the total score. I can select all the variables. And this high and low as my grouping variable. And then I click the define groups. So I have only two groups. One, and this is 2. Okay. Then continue. Now I am clicking options. Again, it is 95% confidence interval. That is 0.05 level. Continue. Then okay. So now I get the, is it visible output?
Yes,
No,
sir.
sir.
Okay, I'm showing you. This is visible now?
Yes, sir.
So this is the mean. Okay, here two groups are there. One group is 1, another group is 2.
Yes.
Okay, and I find that is these two groups, their mean and their standard deviation plus standard error of mean. I am getting all of them. Now, I am going to below.
Sir, what does standard error mean?
Standard error of mean, that is the, you have the normal probability distribution. Do you have the no?
Yes, sir.
So, now this mean 3.78,
Yes.
to what extent away from the normal distributions mean.
Okay.
Okay. So that is the standard error of mean.
Okay.
Sir,
Now I get all the variables, and I have noted the confidence interval also. Okay. And this is the t-test, and whether it is significantly different. Yes, significantly different. The two groups are significantly different.
Yes,
And
sir.
based upon the t-value, you can tell that is in which group maximum difference is there. Okay. For example, new strategies. There you find higher t-values. Okay. That is 9.667. Again, 9.9 something. So this is higher. That means maximum difference in new strategies. So this thing you can get it. No, there is another variable. Sorry, I have done mistake. There is another variable 10. Here we can find out the difference very high. 10.
Yes, sir.
Okay, that is the feedback. So this is the first, and maybe this is the second.
Yes.
So in this manner, you can order the variables with respect to the significant difference. Okay. And here you can find out the confidence interval. And this is the t-test, minus 18.25. Okay. And you can get, that is, all the values are significantly different. That means the two groups are significantly different with respect to these variables. This is clear?
Yes.
So here independent variable is the group. And the dependent variables are these items. And you have noticed the maximum difference occurs in case of the feedback. Okay. So in this manner, we can study the mean difference. Now,
Excuse me, sir.
yeah,
Sir, I have a doubt as to
yes.
like how to decide on certain data whether we should use one sample t-test or independent t-test.
No, one
Independent
sample
sample t-test.
t-test, yes, one sample t-test means you are not considering the two different groups.
Okay.
Because here you can, I'm again showing you one sample t-test. Oh, I think it is already there. So I can show you from here. Yes, one sample t-test. Okay, you do not find the two different groups. It is
Yes,
the
only the
single.
total score.
Huh. Okay, so that is the one sample t-test.
Okay, sir.
And this is the group.
Okay, sir.
Sir,
Huh.
sir, but we can still choose number of variables, multiple number of variables in one sample test.
Number of variables.
Yes, sir.
Yeah,
Like
that
you
is
have chosen.
possible.
Okay, sir.
That is possible. So you are telling this all the variables. Yeah, that is possible.
Okay, sir. Thank you, sir.
So, sir, if we can choose a number like n number of variables in both the sample, then what is the difference? Like, for example, if
Yeah,
I
because
have
I am
certain
not
data.
using this one, right? This is the
Okay.
test variable only. So now I am clicking it. So this is the one sample t-test.
We have not used the independent variable in one sample t-test. That is the major difference, right?
Yeah.
Okay, sir.
Here I am thinking that is the confidence interval mainly. Just you check this carrier impact. Okay. The carrier impact t-test is 64.44. And that is significant. Okay. This mean difference is not the two groups. One is the sample data, another one is the population mean. And this is the 4.05 and 4.31. And here you can find out 4.18. Okay. So 4.18, that is within this range, 4.05 to 4.31. Clear? The mean should be within this range. For example, next one is 4.17. That is also within the range, 4.05 to 4.29, within this range. Okay. I think now it is clear to all of you.
So can you please once again explain that how should we choose this 4.05 to 4.31?
No, there is a specific formula. You have to write down that formula. That is using the standard error of mean. Okay, some formula is there, but
Okay.
I am not teaching here the formula. That is available in the basic statistics books. Maybe
Okay,
in the Garrett, Guilford, from there you can get the formula. Any basic statistics book you can get. But SPSS gives you the result.
So,
Yes.
could you please explain this 95 confidence interval again?
Okay, just to imagine the normal probability distribution. So 1, 2, 3. 1, 2, 3 means 1 SD, 2 SD, 3 SD. Okay. And if it is your Z value, that is your standard score, 1.96, that means it is 95%. If your Z value is 2.58, then that will be 99%. So please you read the basic statistics books. That is not here. Here I am telling you only the SPSS, how to do the SPSS, particularly for your data analysis, and how do you interpret the data. Any more question? Okay, so I'm stop sharing.
So if there are any more doubts, can we just write it at the end of our assignments which you are submitting? Will that be okay?
Yeah, you can, definitely. You can write in the group. I will write there.
In the WhatsApp also and in the assignment also, if it is regarding the assignment.
I have already written the some of the answer for yes, Kavita.
Yes, sir.
What is the purpose of research design? I have
Yes,
written.
Okay, sir.
Okay. So now I am closing. Huh? Good night. Best
Thank you
wishes
very
to all
much,
of
sir.
you.
Good night.
Good evening,
Thank you,
sir.
sir.
Yes, sir.
Yes, welcome.